Hello, in this video, I'm going to talk about the use of error measures in measuring motor skill performance. So accuracy, error measures allow us to assess performance when the goal of the skill is accuracy. So like reaching to grasp a cup. So if you're inaccurate, you might miss the cup entirely or knock it over or not produce enough force to lift it. Throwing a dart at a target, driving a car down the street. So if the goal of the skill is to do it accurately, then we can use error measures to detect the difference between what the goal was for performance and what the actual performance was. So spatial accuracy is when we need to be accurate in spatial terms, like there's space dimensions that count, that really matter. And temporal accuracy is accuracy related to time. Like you got to get the timing right. Like hitting a baseball, you have to get the timing right to hit that baseball. Spatial accuracy, if you're trying to hit a target with a dart, you got to get that right in terms of spatial dimensions. So the types of errors that we can detect inform us about the possible causes of the problems. So we can detect whether there's inconsistency or bias, and that's an important difference in terms of how we correct and improve that performance. So inconsistency is if the performance varies from trial to trial. So it suggests that the basic movement pattern required has not been acquired yet. So if there's inconsistency in the accuracy of performance from one trial to the next, it means that that person needs more practice and to work more on learning that movement pattern that's required so that they can execute it more consistently. The other problem could be bias. So in that case, they've learned the movement pattern, but their performance is biased in a certain direction. So like maybe they tend to swing at the ball too soon or too late, or they're throwing the dart to the left consistently. So their performance is biased in one direction or another, whether that be spatially or temporally. So that suggests that they've learned the movement patterns, but they're having difficulty in adapting to that performance environment or to that situation. So error in one-dimension goals. So simple movements occurring in one dimension. So that could be like how many degrees of knee extensions, like maybe they're rehabilitating after a knee surgery or something like that. And maybe we want to achieve a certain amount of knee extension and they are falling short of that. It's easy to detect the amount of error. It's just the difference between the goal and the actual performance. Same with something like speed of a baseball pitch. Maybe there's a certain goal of what speed you're aiming for, and whatever speed you fall at is, the difference is the amount of error. Okay, so very easy to calculate in discrete movements that are simple and occurring in only one dimension, whether that be spatially or temporally. So absolute error is the absolute difference between the performance on each repetition and the goal, or it could be the average. Okay, so what I just described, where it's just the difference between the goal and the actual, that's the absolute error. Now, absolute error is without a plus or minus sign beforehand. So it's not telling whether it was too much or too little, or too, like if you're aiming for throwing a dart at the target, it's not saying whether you were off to the right or off to the left. Okay, it's just saying, here's how much you were off by without giving a direction. Constant error is the signed deviation from the goal. So it's basically absolute error, but where it does give you in which direction were you off by. So it does say you were too far to the left or too far to the right, or you did it too fast, or you did it too slow, or whatever the error was. Variable error is essentially the standard deviation of the person's constant error scores for a series of repetitions. So that gives an index of variability or consistency of performance. So over several trials, how much did your error change? And that's useful to tell, like we talked about on the previous slide, we talked about consistency and bias. So the variable error helps you see, like, are you biased in the direction of the right? Like you're throwing the dart to the right too far. And so variable error tells you that over several repetitions, you're biased, or over several repetitions, maybe you're all over the place. And so it's a matter of continuing to learn that skill. Now, then we need a way to assess error in two-dimension goals. So that's where we have movements that are more complex. So we have a vertical and a horizontal component to that movement. So it's not just one factor. There are two dimensions. There are two factors to consider. So it gets a little bit more complex here. And this is where we get into a slight amount of trigonometry. But you would put the error in one direction and the x-axis, and the error in the other direction on the y-axis. And then you would calculate the hypotenuse, and that is your radial error. So radial error is functionally similar to absolute error. So it tells you the amount of error, the difference between the goal and the actual, but in this case, taking into consideration two different characteristics or complexities of the movement instead of only one. Let's see. And then, yeah, it gets a little bit more complex here. When we're doing trigonometry like this, the sign doesn't tell us much. So like if we're looking at one dimension, then a plus or a minus sign changes everything. But here, plus or minus is going to give us essentially the same hypotenuse. It doesn't give us as much information. So it's a little bit tougher. And in practical applications, in this case, we will tend to look at bias and consistency qualitatively. Like you'll qualitatively watch what they're doing, see where the ball is landing, see where the dart is landing, because sometimes qualitative observation is more practical and more useful. Like you can observe that the dart went to the right of the target each time, or you can see where the ball landed when you're playing golf or whatever it is. So in some applications for two-dimension goals, qualitative assessment is going to be more practical. All right, so everything we've talked about up until now in this video is about discrete skills. Continuous skills have to be a little bit different. So continuous skills in this context would be like walking, and the aim is to walk along a certain pathway or to steer a car along a road. Those are a couple examples. So if you want to assess the amount of error, like walking along a pathway, how much error was that, would be how much did you deviate from that pathway. So in that case, you would use software that would conduct pretty complex calculations, where it would be taking samples at specified time points along the travel or along the length of that movement, so that you can see, like, at these intervals, where were you in relationship to the pathway that you were supposed to be walking along? And then it would calculate a root mean squared error score for you. So again, a little bit more complex, and it's not something you would do without the right equipment to both detect and then compute and calculate what the error is. All right, thank you so much for watching. That's all I have for you in this video.